to Easy BTech channel. So in today's class, we will see about error detection and correction. So why we need error detection and correction? So whenever we are sending the binary data from one location to another location by using transmitter and receiver, right? So noise will get added. So whenever we are transmitting the bits, binary bits from one place to another place, so in between, so the channel will add some noise, so at the receiver, some of the bits will get corrupted. At the receiver, some of the bits will get corrupted. So we will not receive the exact data, whatever we are sending from the transmitter. So some of the bits will change due to the noise that is inherently present in the channel. So that's why in order to detect the errors that are occurred while sending from the transmitter to receiver, we will use we have to use the error detection and correction concept. So what we have to do means, so we will add some extra bits to the data bits, or these data bits are also known as information bits. So we will add some extra bits. So after adding these extra bits to the data bits or information bits, so those are known as code words. Those are known as code words. Code words are nothing but data bits data bits plus extra bits. Along with the extra bits, whatever we will add, so some of these two are known as the code words. Some of these two are known as the code words. So in general, so these code words are divided into two types. One are valid code words, the other one are invalid code words. One are valid code words, the other one are invalid code words. So at the receiver, whatever code word we will receive, that we will check whether we received either a valid code word or invalid code word. Invalid code word. If we receive an invalid code word, that means some error is happened. Some error is occurred. If we receive an invalid code word, so that means an error is occurred in the channel due to the noise present inherently in the channel, right? So in order to detect this, we will add extra bits at the transmitter, right? So the total code words that are possible, with the bits are divided into valid code words and invalid code words. Any bit error, it may be 1 bit or 2 bits or 3 bits, changes a valid code into an invalid code word. So whatever may be the bit error, it may be single bit error or 2 bit errors or 3 bit errors. Any bit error may change a valid code word into an invalid code word. So how to detect this? So in this, the important concept or the definition is, or how this we will measure is, means by using the parameter called dist ci comma cj. By using this parameter dist ci comma cj. So what it denotes means the number of bit positions. The two code words differ is represented by the distance between the two code words, where ci comma cj are any two code words. So this will give you the number of bit positions in which the two code words differ. For example, if you take two code words 01001 and 11100. So if you compare both the code words, You see how in how many bits both the code words are differed. So here in the MSB both are differed. So here also one, here also one, and here also there is a change. Here it is having 0, here it is having 1, and here it is having 1, and here it is having 1. So the distance between these two code words, distance between these two code words is nothing but 3. So it indicates the number of bit positions in which the two code words differ is nothing but the distance between the two code words. So here if you see, so the two code words are differed in 3 bits. So that is where the distance between the two code words is 3. The distance between the two code words is 3, right? So, and next thing is for detecting k errors. For detecting k errors, so the distance must be at least k plus 1. The distance between two code words must be at least k plus 1. So that means, so if we have to detect one error, if we would like to detect one error, then the distance between two code words, any two code words must be at least 2, must be at least 2. So to detect one error, the distance between the two code words should be 2. So whereas if we like to detect two errors, then the distance between the two code words must be 3. Whereas if you would like to correct the errors also, so first for correcting we have to detect the errors, then we have to correct the errors. So for correcting k errors, the distance must be at least 2k plus 1. The distance between the two code words should be at least 2k plus 1. So for example, if you would like to correct, if you would like to correct one error, the distance should be, the distance between two code words should be 3. So to detect error, the distance between two code words should be 2. So whereas if you would like to correct the error also, if you would like to correct the error also, the distance still should be more. So if you would like to correct two errors, if you would like to correct two errors, the distance between the two code words should be 5. So whereas to detect it should be at least 3, whereas to correct two errors it should be 5. So if we correct more number of errors, the distance between any two code words should be as high as possible, as high as possible. Next. So one important concept is called the parity code. Parity code. So this is used for only error detection, not for error correction. So parity code is used to identify only whether error is occurred or not. We cannot we cannot correct the errors. We cannot correct the errors. We can only detect the errors. So how we are going to detect the error? So what is meant by parity? What is meant by parity? So parity bit are nothing but is the extra bit we are adding. We are adding extra bit along with the data bit to detect the error. So this extra bit is called the parity bit. In order to detect the error, in order to detect the error to the data bits, we are adding one extra bit. We are adding one extra bit. So we are adding only one extra bit, so it can be either 1 or 0. It can be either 1 or 0. So this extra bit is called parity bit. So how we are going to add this parity, when we are going to add and when we are going to 0. So the parity of a given binary word. So how we are going to define for the given binary bits. it is defined or it is given by the whether we would like to have number of ones are odd or even. So how we are going to define the extra bit that we are going to add, whether it should be 1 or 0 means, so the total number of ones in the code word. So if we add the extra bit along with the data bits, that is called the code word, right? So it is decided by whether we should like to have the number of ones odd or even in the code word, in the code word. So that is how we are going to decide whether this extra bit is 1 or 0. So whatever this bit we are adding is called the parity bit to make the number of ones even. Even. So then it is called even parity. It is called even parity. If we make the number of ones odd, then it is called odd parity. So parity with respect to one can be even parity or odd parity. So if you would like to have the number of ones in the code word, if they are even, then it is called even parity. Even parity. And similarly we can also have odd parity. If it is odd parity, then the number of ones in that code word, number of ones in that code word should be odd. In that code word should be odd. So we'll see with the help of an example so that we can better understand. So what is meant by parity bit? Parity bit is nothing but the extra bit we are adding to the data bits so that the number of ones in the code word may be even. If the number of ones are even, then it is called even parity. If the number of ones are if the number of ones are even, it is even parity. If the number of ones are odd, it is called odd parity. So depending on whether we would like to have even parity or odd parity, so the extra bit will be either 1 or 0. Either 1 or 0. We'll see with the help of an example. So we are considering 3-bit binary code. So we are considering 3-bit binary code. So total possible combinations 2 power 3 are 8. So starting from 000, 001, 010, 011, 100, 101, 110, 117. So total 8 possible combinations we have. So if we would like to have odd parity, that means the number of ones should be odd. The total number of ones along with the parity bit in the code word should be odd. So here the number of ones, there are no number of ones in the original message. To make the parity odd parity, we should make the parity bit as 1. We should make the parity bit as 1. So along with the parity bit and the information bit, so this is the new code word. New code word. So if you take 001, already the number of ones are odd. So we would like to have odd parity, so the parity bit should be 0, so that the total number of ones in the code word are odd. So here for the next message 010, so here also the number of ones are odd, already the number of ones are odd, so the parity bit should be 0, so the total number of ones in the code word are odd. So here if you take the next message 3, that means 011. So here the number of ones are even. Number of ones are even. So we are having odd parity. So we should add the parity bit as 1 so that the total number of ones are odd. So for the next message 100. So already the number of ones are odd. So we should not make any extra parity bit as 1. So parity bit should be 0. Next for 101 the number of ones are even. So we should make the parity bit as 1. Next 110 the number of ones are even. So for odd parity we should have the parity bit as 1. Next for 111 the number of ones are odd. So we should not make the parity bit as 1. So we have to make 0. So for odd parity, so we should have the total number of ones including the parity bit as odd. So this is how we have to add the parity bit, either 1 or 0 depending on parity. Next, if you would like to have even parity, we would like to have even parity. So here for 0 0 0, so we should not make the parity bit as 1. So if you make the parity bit as 1, the number of ones are not even, the number of ones will become odd. So here we have to make the parity bit as 0. So here we would like to have odd parity, so the total number of ones along with the parity bit should be odd. So that's why here we have added 1. So whereas here we would like to have even parity, we would like to have even parity. So the number of ones should be always even. So the parity bit we should add 0. So here for the next message 0 0 1, the number of ones are odd. So we should make the parity bit as 1. So the total number of ones are even. So here also the number of ones are odd. To make even parity, we should make the parity bit as 1. So here the number of ones are 2. That means it is even. So the parity bit should be 0. Here for the next message 1 0 0. So the number of ones are odd. To make even parity, the parity bit should be 1. Next 1 0 1. So here the number of ones are even. So we should not add any parity bit as 1. So the parity bit should be 0. Next 1 1 0. Here the number of ones are even. So the parity bit is 0. So here the number of ones are odd. So to make even parity, so we should add 1. So this is how we have to make the parity bit 0 or 1, whether we are sending with respect to even parity or odd parity, even parity or odd parity. So if you make the number of ones are odd along with the parity bit, so then it is called odd parity. If the number of ones are even in the code word, then it is even parity. Right? So to detect the error, we are adding the parity bit. So here one important point that we have to remember is only odd number of bit errors we can detect. Odd number of bit errors we can detect. Even number of errors, even number of bit errors, even number of bit errors we cannot detect by using. Bit errors cannot be detected by using parity, by using parity, by using parity. Why? Because, so for example, if you receive the, or if you are transmitting the code word, if you are transmitting the code word 1 0 1 1 0, that means we are sending the code word by odd parity, odd parity, right? We are sending the code odd parity. So for example, if one error is occurred, for example, bit one bit error is occurred, so it can be in any location, either 1 can be changed to 0 or 0 can be changed to 1. So for example, if this 0 is changed to 1 at the receiver, for example, if this is the code word 1 1 1 0, so we will inform the receiver priorly we are sending the code word with respect to odd parity. So at the receiver, it will check whether the number of ones are odd or even. So if the receiver checks for the odd parity, but here you see the number of ones are even. The number of ones are even. So the receiver will know, it can detect the error, it can detect the error somewhere, the error is occurred, so it will send a signal to the transmitter, please send the signal again, send the code word again. So there is an error in the received code word, you please send the code word again. So if one bit is changed, we can detect whether error is occurred or not. That means odd number of errors, any odd number of errors can detect. For example, if the received code word is this, if the received code word is, so this is the transmitter code word, but the receiver is receiving 0110. So if this is the code word is received, that means so this 1 is also changed to 0, whereas this 0 is changed to 1. So that means two errors occurred. Two errors two errors occurred. So the receiver will check for odd parity. You see here the number of ones. The number of ones are odd. So the receiver will come to a conclusion that there is no error is occurred, but two errors are occurred in the receiver received code word. So by using the parity bit, we can detect only odd number of bit errors. We cannot detect even number of bit errors. So that is the limitation of the sending the message with respect to parity. We can detect only the odd number of bit error. We cannot detect even number of bit error, and also we cannot correct. We cannot identify where the error is occurred. Also, by using the parity concept, we can only detect the odd number of bit errors. We cannot correct, and we can also cannot detect if even number of bit errors are occurred, right? So thank you for watching. I will stop here. I request everyone to subscribe Easy Tech channel and share to your friend. In the next module, we will see the Hamming code. By using the Hamming code, we can detect the error, and also we can correct the error also. So that is the advantage of the Hamming code. Thank you for watching.